Yeah,
All right.
we're gonna get a nasty gram if we don't record it.
Oh,
That's
okay.
right.
Good to know. So I'll have the recording, have the call recording. I send that to you guys as afterward.
Well, there's a link that you're supposed to send. You're supposed to like put it on a, a Google Drive site or something like that, and then provide a link.
Yeah,
Not to us. There's an address for Esra that you send it to.
yes, I do remember. And this happened last year too. Just upload Google Drive, and then you send a Google Drive link over to the submission, so or the email. But yeah, I'll take care of that afterward. All right. Well, I think if you want, we can just dive into our rocket design. I'll show you the rocket parts individually, and then we can kind of talk through, the general design of it. If that's all right with you guys.
Okay, Google, stop. Sorry, that was me on my side.
Okay.
Yeah, I would start at the nose cone and work your way down.
All right, sounds good. So I have the parts right here. Blake, you want to be on here, I can just, let me see, flip this around. There we go. And then here, Blake, you can just start talking through what do you have here.
All right, so this is our nose cone. It's fiber wound or wound carbon fiber. We also have an aluminum tip. The whole thing is connected with a G12 wound carbon or fiberglass coupler tube that is inserted into the upper body tube and the top of the nose cone, and that connects the two. And we have screws that go in here that connect the payload bay to the nose cone to ensure that it all stays together during launch.
Moving down. Yeah.
And this is our upper body tube.
Yep.
This is, I believe, 48 inches in length. Again, G12 fiberglass. We have slots cut here for the keys, set up the electronics. We also have holes drilled here for the electronics bay, so that way you mount it in place. And we also have what it's called again?
A shear pin.
Shear pin hole. Right
Yeah.
here. So you have 8 shear pin holes and 4 at the bottom where it connects to the lower body tube.
Yeah, and by the way, there's a little bit of tape right here. That's what you're seeing. We're taping it just for painting, but there's generally a hole through the body tube here.
Yeah.
Yeah.
And then continuing on to the lower body tube. This is the coupler tube that connects the lower body tube to the upper body tube. This entire length of the lower body tube is 42 inches, I believe, and then with another additional 6 inches here from the coupler tube length. We have our launch pin holes here, or other side, yeah. Those are vent.
Yeah, those are vent holes. These are the launch lugs. Yeah, rail buttons technically. Yeah.
And what size are they?
They're 15-15.
Okay.
Then we have down here, we have the fins we cut. We cut them out of 1/4 inch G10 fiberglass, and then we did 3 layers of carbon fiber layup over top of it. Yeah.
Were you not able to get a rail button down? Oh, you do have one. Never mind.
It's kind of hidden. Yes, it's right there. Yeah, there we go. Yeah, you want to talk about the thrust plate at all?
Yeah.
Stuff? Yeah.
So we have center rings in there just to keep the motor in the correct place. Those are just, I believe, balsa wood that we cabestilled in. We also have a carbon or a fiberglass thrust plate that goes on the end of this that the motor will rest on.
Yeah. Yeah. So I think that's it on the airframe side. Just kind of the structures of it. We did actually test launch this out at Seymour. I don't know. Jim was actually there, so he can probably, he knows a lot about it. But we were able to fly this on an N2501 up to around 19,000 feet. And yeah, it went pretty well. Full recovery. We had a couple of damages on the way down when the rocket landed. But other than that, it was a good test flight. So it gives me some pretty good confidence in the structure going to Spaceport.
Hey, Ryan, can I ask what was the damage to the holes holding the altimeter bay?
Yeah. So I mean, we've already repaired that actually. But it was these little like nuts. I don't know if you can see them on my camera. they had come loose. I think the cabosil must have been like not sanded down enough. But we were able to sand them down again and then reapply another layer of resin with cabosil mixed in, and then it's been reattached.
Okay.
Yeah. I'm not sure. I don't know how well we did it the first time, like with these little like nuts on the eBay.
Yeah, I think the first time we had a bunch of the new members work on it.
Yeah.
The second time we did it, we had a bunch of the more members do it.
Yeah, it's just one of those things that I feel like it's hard to teach because it's like not something you think about initially, but then like once things like once it falls off, you're like, okay, yeah, we should probably do that next time to sand it down a little more heavy next time. So, but yeah, our eBay, it's there's some work on it, but we probably resin out or sand down the resin outside the current status of our eBay right here. All right. Well, actually, there's actually one more thing I did want to kind of discuss was our zipless zipless coupler bulkhead right here. I'll show you guys what I'm talking about. The bulkhead itself actually broke off. I think kind of due to some similar reasons. We haven't repaired it yet because we want to size up our motor to make sure it's in the right spot before we put it in. But yeah, that was something that we are going to try and change from the first time we did it. Is that the bulkhead probably wasn't, at least the connection point between them probably wasn't sanded down enough. But yeah, that's another thing we're going to try to change between the test flight and now. All right, so I think that's mostly it for structures, airframe stuff. If you guys have any questions now, you can feel free to ask. But I was gonna have Josh, if you want to talk about the eBay design, about how we designed a sled and all that. So you can see you show in front of this camera, yeah, everyone. So you just come around here and show. Yeah, so I'm having Josh come over and talk about the eBay sled. But feel free to ask any questions anytime if you have any.
Yeah, eBay sled. eBay sled. We have two separate, completely closed loop systems. So we'll have a primary telemega computer with a backup easy mega computer. They're separate of each other, so if there's any failure, they'll completely independent and not able to affect the other. With the programming, we've already tested it, obviously, in a flight launch or a test launch, and everything went well. GPS was working, and for the design of this, we have two all-thread holes through the centers. That'll keep it from rotating, and all the wiring will come through these holes here, and then once we attach it to like the igniters, like the black powder charges and whatnot, it'll come up through holes into the with the all thread here, and then be connected onto that. I think that's about it for the design. We're trying to keep the wires nice and concise back here. We obviously don't have it wired up as into the rocket right now, but we're going to keep this like really organized and make sure that the wires don't move mid-flight so that there's no potential disconnections. And then we just have our key switch holes, which perfectly line up with the two holes on the body tube. With those, like that.
Mm-hmm. Yeah.
Yeah, I think that about covers the eBay.
Yeah. Good. Thanks for going over that. Yeah.
Before you move on, could you bring the eBay back again? Okay. So your battery's on the same side as your altimeters.
Yes.
And how are they fastened down?
So there is.
You need
Velcro.
to close up with the camera.
This one right here.
Yeah.
Mm-hmm.
So this is Velcro in here. It's just resin down, and then they just attach Velcro, and then once we actually put it in the rocket, we put a little bit of tape just on it just to make sure that they stay in.
ideally you would have some holes for a tie wrap because they can move.
Yeah,
And they're going to be able to move the Velcro isn't indestructible,
yeah.
and they can move.
We do
They
have
can
like,
move both forward and back because they're not set all the way into that plastic.
yeah, that's true. It doesn't have too much wiggle room, but I do agree that the plastic could be like a little taller. But seems solid, and with the Velcro and the tape, obviously with the test launch, it wasn't a problem whatsoever. And yeah,
Well, I would hate for you to lose connection with your altimeters
yeah,
and have bad things happen.
Right, Elaine, did you say it was a tie wraps? What was that? What you said?
You know, zip ties?
Zip ties. Okay, yeah, zip ties.
Okay.
Yeah, sorry.
Yeah, you
Yeah.
probably want to use 2 of them for each battery.
Yeah.
And they don't have to be real, real thick ones. I mean, they can be pretty thin, but you need to have 2 of them, and they just need to go, crosswise across the battery. Now, ideally, you also go up and down.
Yeah, but I don't know if there's room on that. I mean, do you have time to reprint that sled?
We should. The lab is CIW still open over?
I don't know. I have my own 3D printer. That.
Well, the other thing is, how tight is that in your coupler, your avionics bay?
It's basically a perfect fit with the upper two.
Yeah. So you're going to have a hard time getting those zip ties to fit in. You're going to have to make, if you could move the batteries closer to the center.
Uh-huh.
And
I think there might be enough room on the side to get them in.
You do think there's enough room? Okay.
I can't tell for sure, but I think it's just show us the face of it again.
There's I don't know how well I'm able to show. There's a little bit of space, but
yeah, you've got to stay inside the perimeter of the board there.
Yeah.
But I think there's enough room if you could just show it to us. Point it at us so we can.
Yeah, make a notch there with a drill bit.
Yeah, you could use a notch or just drill a hole.
Yeah,
There's enough room that you could do it there.
I think drill a hole or just notch it or something.
Yeah, I would just drill a hole, but one thing you want to accomplish with it when the zip ties go across the battery is to make sure that the battery is down pretty tight. Because I don't like doing the up and down zip tie because of the little circuit board at the top of those batteries.
yeah.
So what I would do is, well, if it makes sense, I'd take the Velcro out. And so you can maybe seat the battery down in that containment a little further. And that'll keep it from moving around, once you put the zip ties on there.
Okay.
And you might look at and see if that option would work. You got to be careful about that, the top of the battery, that it doesn't get deformed.
Yeah.
But you don't want them moving, in any direction. So you got to make sure they're secure in there. If you're not taking care of it now, you will be when you get to New Mexico. I guarantee it.
Okay.
So Jim, are you their flyer of record?
Yes.
Have they involved you in the design and building of this at all?
Yeah, sort of. I see the plans and I see the kind of what the components are, but I don't always see the product like the limiter bay, because usually by the time we get to launch, it's sort of been assembled. So,
Yeah.
I don't always see it. So that's why I like this video overview.
Yeah. Yeah.
All right, so yeah,
Proceed.
yeah. Sorry, go ahead.
That's what I said. Proceed. Go ahead.
Yeah, yeah. So just to be clear, you said they had 2 zip ties horizontal for each battery. Move the batteries closer to the center line of the board, and yeah, remove the Velcro.
Yeah, I mean, you might not have to reprint the board. I mean, you just have to try some holes. I mean, you know, I would put holes right next to the side of the container. I can't really see, you know, point it at me and show and point at it and turn it like that.
So you like
and
about right there.
well,
right there.
you need them right at the edge of the board there.
All right.
Yeah, right there. If you can get holes right there and the same location right on the other side of the containment, right?
Yeah, just like that.
I think it'd probably
Yeah.
be possible.
And then if you use zip ties that are not really big, they'll be flexible enough that they'll hold the battery down well. You know, if you use zip ties that are too thick, it makes a big round turn and it doesn't really do much. So you just want to use smaller zip ties.
Okay.
Yeah, that makes sense. Actually, I did have a question for you guys. For Spaceport, I do remember the competition authority saying that we have to use batteries from Altus Metrum because we're using like Altus Metrum products, right? I did order 2 batteries from Altus Metrum, which are the same voltage as these ones. They're 1S, 3.7 volts, but the milliamp hours is a lot less. The ones that we have for now, these are 2,000 milliamp hours. The ones that I bought are 900 milliamp hours. Do you think that could cause an issue at all with like, you know, ejecting like battery charges and stuff?
So the reason behind the Altus Metrum batteries is because that's what the manufacturer sells to go with it. And that's for LiPo batteries. So these are also LiPos?
Yeah, these are also LiPo batteries.
That would not be a question for me. That would be a question for the safety people. You know, I would post it on the forum on HeroX.
Okay.
And go with what they tell you.
All right. Sorry.
Yeah, my belief is that you need to use the actual batteries provided by the supplier. And I think that's really the condition that they're adopting to allow the use of LiPo batteries at all.
Yeah.
And so I would, you know, you might be allowed to fly with them like that, but they're really trying to minimize the size of the LiPos and you know, they're allowing what the vendor sells. So you may, you know, you may run into somebody that says it's not a problem, and you may run into somebody that says that it is. And I think you'll find that the LiPos that they sell, those 850 are plenty large for the service.
All right.
So that's what my recommendation would be, because if you end up getting there and somebody doesn't allow it, then you're in a pinch.
Yeah.
So
and I would agree. I would definitely agree, Jim. Use whatever the manufacturer's suggestion is, because
yeah,
the suggestion at Spaceport is to not use LiPos.
Yeah, if it was up to Spaceport personnel, they wouldn't allow LiPos at all. And so the wiggle room is that they let you use them if they're specifically sold by the manufacturer. So, you know, it's cheap insurance just to go that route.
Yep.
And
lots of us have been burned literally by LiPo batteries that caught fire in the field.
Really? Are those like
yes.
put out or something? Like fire extinguishers like don't put them out or something like that. That's what I've heard.
Well,
they literally can catch fire, and particularly if you have a hard landing and they're
and that's what happened.
They'll just start burning. And you can't put them out.
That would also go for your payload, because at our field, what caught fire was somebody's payload because it had a hard landing.
Yeah. I did talk with the payload team, see what they use. But yeah, I have ordered LiPo batteries that from so I have them in order. They're taking a really long time because the university ordering system is really difficult with LiPo batteries that are like dangerous chemicals. Like half the stuff we use, the university considers dangerous. So it just makes it really hard to order it through them. But hoping to.
Well, they're not very expensive. If all else fails, just buy a couple of them.
Yeah. So we should be. All right. I think that's mostly it for recovery electronics. Let's see. Oh, we should talk about parachutes maybe.
What are you doing on top of the bay? How is the harness being connected to it? I know I've seen it, but maybe just show us again.
Yeah, on top of the eBay, you mean?
Yeah, top and bottom, right?
Yeah. Do you want to talk about like? Or...
I'm sure.
Okay.
So we just cut a G10 bulkhead at the rest of the top of the electronics bay. Then we have two all threads that go through the electronics bay that keep from rotating, and then we have an eye bolt, and then a lock nut on either end of the bay to keep it in place, and then just the shock cord will connect to that.
Okay. I know in the past we've talked about how to tie off those eye bolts so they can't turn open.
Yeah, like the Kevlar strap.
Pardon me?
You're talking about the Kevlar strap method?
Yeah.
Yeah, I remember that.
Yeah, I would. I think you probably need to do that. And the reason is that you really technically can't rely on nylon nuts from unscrewing.
Like these ones?
Yeah, and particularly if they're not all the way on the thread. But in general, they're kind of a one-use thing. So if you're taking them on and off and on and off and so forth, you're losing the technical intent of the nylon lock nuts. So what you need is on the lid, there needs to be another eye bolt, and it can be a small one like you'd use to hang a picture or something like that. It doesn't have to be very large, and screw that on someplace, out towards the edge of the board where it won't be in the way of anything. And then you can use safety wire, or you can use Kevlar thread, like 1/8 inch diameter Kevlar is enough for this thing, and then you just tie them off. And if you don't do that, you're going to end up doing it in New Mexico.
Yeah, that makes sense. Yeah, well, actually, right now we have a hole drilled out already. Actually, if you take a look here, this center hole I'm pointing at, this is for the main all thread that will hook onto the shock cord. We have a second hole that is for another all thread that goes through the eBay to prevent it from rotating. We can actually just attach an eye nut to this one instead, and then tie a Kevlar strap to connect both of the eye nut for that whole shock cord, and then the eye nut that'll hold the eBay from rotating. So that's something we can actually do. It should be pretty simple.
Yeah, that sounds fine.
Okay. Quick question on that. So if we have the Kevlar strap tied, does the eye nut that holds the shock cord, do we still need to put a nut or a lock nut on that, or is just use a regular nut?
It can be your preference. I mean,
okay.
I certainly have some that have a nylon lock nut on them, and then I have the Kevlar strap as well.
Yeah, or you can put some what is it? Thread lock on it.
Will it be removable if you put thread lock on it?
Yes, certain ones are.
Yeah.
So, okay. All right.
It's not really permanent. It doesn't make a bond.
Okay.
It just makes it hard to unscrew.
Okay, that's good. It's like and at Seymour, we had a situation where we actually had to unscrew the eye nut to remove the eBay sled so we can do a couple things with it because we had some issues with I think orientation. So I think having it to be relatively easy to remove is nice. That's why I do like the Kevlar strap method. But yeah, we can definitely look into some thread lock as well. For those, yeah. Kevlar strap. Okay. All right, let's see. Yeah, I guess that kind of goes right into recovery. Yeah, I guess. Yes, yeah, we have parachutes out there.
Yes, we have 2 parachutes.
Yeah. Would you go grab the parachute bucket?
Yeah, I can grab it.
Yeah. Well, generally on the parachute side of things, just kind of like talking through sizing. Let me see. Let me find my open rocket. I believe we went at Seymour. We went with a 24-inch drogue, and I think a 60-inch main. I believe. I'll have to check. Let me check my work before I tell you guys the wrong information. Actually, no, sorry. It was okay. So the main we used at Seymour was 96 inches. So that's a 8-foot. And then the drogue was a 36-inch drogue.
No, that one's not updated. We
It's
used
not-
24-inch.
Oh, we used 24-inch.
Yeah.
Do you remember the exact sizes we had?
We used 24-inch toroidal for the drogue, and then 60-inch toroidal for the main.
Okay. 24-inch toroidal, you said?
Yeah, it ran open rocket calculations with the O motor in. We got a set rate of 98 for the drogue and 28 for the main, I believe.
Okay. And then what was the size of the main again?
60.
Yeah, 60-inch. Okay. I see. I had the toroidal main.
Don't take them out or just.
If you can find them, yeah. And these work pretty well. I believe the main landing was a little harder because some of the carbon fiber on the fins kind of got roughed up a little bit, but we were able to repair those pretty well. So we may up the main size a little bit to like a 72-inch. We have one of those. But other than that, I think parachutes worked pretty well for us. Okay, any comments on that?
I saw that you said you got 84 feet per second on the drogue.
Yeah.
Did you measure the main descent rate also?
Yeah, we did measure that. Actually, I have the flight data, so I can show that. Yeah, let me see. Yeah. All right, flight statistics. So our main descent rate, so our drogue descent rate at Seymour was 84 feet per second, and our main descent rate was 35 feet per second.
Okay, yeah, you need to up your main.
Yeah, let's see. I'll up the main parachute. But so the descent rate is 84. Yeah. What is the recommended main descent rate? Do you guys know?
Well, many people would say 20, but 25 is probably okay.
So you said 20, 25 feet per second is the goal.
Yeah, and it'll be significantly larger than what you used, so.
Yeah.
hopefully the bag and all that stuff will be.
Yeah.
As well at Spaceport, so probably you need to up the size of the main. Yeah. Oh, is this one we use?
It's one we use.
Oh wait, this one's broken. This one. Yeah, I did not realize that. Good to know. Yeah. Which also, while we're getting parachutes out, I did want to ask if you guys have followed any other teams. Like, do you know how many teams have test launched at this point? Like, not
No. My teams have,
Yeah, like,
but just two. I don't know about anybody else's.
okay. I see.
Yeah, there haven't been as many as planned. I can say that. I've got 12 teams I'm reviewing, and I'm not sure that more than a quarter of them have done a test launch. I mean, I don't think a test launch is necessarily required. It's certainly recommended.
Yeah.
But, you know, I know a number of teams that I'm reviewing plan to test launch and just haven't been able to do it for one reason or another.
And,
Yeah.
you know, a subscale test launch is fine. There's not a lot of places where you're going to be able to go 30K.
Yeah, that's
with a
true.
full-scale motor.
Yeah, I guess we are lucky in Texas to have Seymour.
Yeah.
Yeah.
Both of my teams that I'm mentoring did subscale flights.
I see.
You know, more proof of concept than anything else.
Yeah.
But you know, we're on the East Coast. There's not a lot of places where you can go even 10,000 feet.
Yeah, that's true. But Elaine, where are you based at again?
Virginia.
Virginia. Okay. That's
I'm from Maryland, so I'm pretty close there.
Oh, nice.
I didn't realize, yeah. We have two DC area students. Yeah, exactly. So that's really cool. Come to Austin, launch some rockets, you know, higher launch ceilings and all that. Let's see. Yeah, so you have the parachutes.
Yeah, 20-inch one.
24-inch. Yeah. So we're gonna show you the parachutes. We would happen to find them. Parachutes that we did use. So if our drogue descent rate looks all right, we probably use the same one, even with a bigger motor. It's it's a 24-inch toroidal parachute. I guess to see the full thing.
Yeah, and your descent rate for that wasn't even 100 feet per second, and they would like to see 100 feet per second or thereabouts, so you don't drift too far. So you're good as far as the drogue goes.
Okay.
And for the main, I agree with Jim. You need a bigger parachute.
Bigger parachute. Okay. Cool. Yeah.
I think there's a requirement for the spaceport of 36 feet per second maximum.
Oh,
I think it said 20 to 25. 25, I think, is the maximum.
No, I'm pretty sure it's higher than that. I vaguely recall 36, but we can check that.
Okay.
But remember, at spaceport, you're at higher altitude too, so it's going to come down faster than it did at Seymour. So you have to take that into account. So, you know, make sure you go to the manufacturer's website on the chute that you're looking at and see for your weight what they say the descent rate is, keeping in mind that those descent rate calculators and information are almost always at sea level. So then you have to make an altitude adjustment to estimate what you'll really get. And like I say, I wouldn't plan on being over 25 feet a second.
All right. Makes sense. So yeah, we'll up the main size to either 6 feet or 7 feet. We'll have to check our inventory. Yeah. Actually, by the way, this is something we've been asking about a lot. We couldn't find any legit things online. Do you happen to know the exact CD of a toroidal parachute and the exact CD of a parabolic parachute?
The toroidals are normally billed at 2.2.
Okay.
Although NASA says that the Rocket Man toroidals don't meet that. The Fruity Chutes apparently do, but the Rocket Man don't. The parabolic chutes are typically 1.5.
Okay. Yeah, that's that's good to know because we've been looking online about the CD because the Rogue Open Rocket they ask you to input the CD of the parachute, right? But every time I look online, there's like different answers on the even like rocket forums about what the CD is, and then like NASA standard for all these things. Yeah, we have a couple parabolic parachutes we may try and use, but we'll have to sim them to see if we can get under that 20-25 feet per second main descent rate. All right. Let's see. Do you guys have any other comments or questions about the recovery system at all, or recovery electronics?
So what are your recovery harnesses?
Oh, the shock cords.
Yeah.
Like, do you want to go over these? Or
Yeah, we have.
you're gonna pull them out. We have one right here. Yeah. Come on the other side. I'll pull them out. Yeah, I'll hold them. A big tangled mess right now, but we'll hopefully untangle this in some time in the future, especially before we leave for Mexico.
Yeah, so we have used this lower shock cord, and then we have right now we have two lengths. That one length is 42 feet, and the other one is 24 feet. So our test launch, I believe we had 42 attached to the drogue, 24 to the main. Is that right, or was the other way around?
That's a good question, actually.
I think it was 42 to the drogue, 24 to the main.
42 to drogue, yeah. 42 to drogue, 24 to the main. But I know, like, you mentioned a shock, Elaine, I believe you mentioned shock cord length was one of the issues. We found out that one of our shock cord lengths is actually very, very long, 42 feet long. The other one was 20 feet long. And I do remember we had a longer one before. Oh, I know what it is. So last year at Spaceport, we launched our 2-stage rocket and we lost second stage in the desert. I believe our other 40-foot length shock cord is still out in the desert somewhere.
You're probably not going to get it.
Yeah, I mean, if we find it out there, maybe we can reuse it. But that might be that must be what it was, because I remember we had the length of shock cord needed, but we couldn't find it before. But that's probably what it is.
Ryan, didn't you end up using the my method for recovery on the main?
Oh yeah, the V method, with the shock cord coming out of the upper body tube,
right.
Yeah, we did end up using that. You actually showed us how to do it at Seymour. I do remember that. Yeah.
So Elaine, there's actually, it's sort of an interesting method. I'm not sure how to describe it very well, but I'll say that the team is using a piston, and at the piston, at the top of the piston, there's actually two harnesses. One goes to the nose cone, and the other goes to the parachute, deployment bag, pilot chute. And so when the main gets ejected, basically the nose cone goes down, and the pilot chute deployment bag main goes up, and then when tension's pulled, it pulls the main out of the deployment bag. So it's not a method that you see a lot of people use, but it's really good.
Yeah, what I like to do is, and I do use a 5 times the length of the rocket for the main, especially if the nose cone is heavy for some reason. And is that where you're putting your payload?
Yeah, it is.
Yeah, so your nose cone is how heavy?
Should be around 10 pounds.
Yeah.
Yeah. So I'm concerned about jerking. And when your drogue deploys, that your main may also deploy.
Mm-hmm.
And then you've got a big drift problem.
Yeah.
So that was why I said a longer one. I like to put my chute bag in at the bottom of my of the payload section, and attach the nose cone to the parachute, so that when the nose cone deploys, it pulls the parachute out of the parachute bag. That just happens to be my method. You know, there's lots of good methods. How long is the recovery harness on each of your? How long is each harness on the recovery harness?
Like each side of the V.
Yeah.
I mean,
Well,
one of our
yeah, just for clarification, Elaine, the main method that I'm talking about has two harnesses.
Mm-hmm.
I have a
One to the nose cone and
One to the pilot chute.
one to the main pilot chute. So in that configuration, since there's two harnesses, the nose cone doesn't pull on the parachute. And so that's why you have to use a piston with that method.
Gotcha. That makes sense. And actually, when I think about what I'm asking you is, I'm not concerned so much about on the main for the length of that particular one, because you want that one to come off. But for the drogue, how long is that one? That's the one I would like to see longer.
Yeah, that one is 42 feet, right?
And how big is your rocket?
10.5 feet tall.
Yeah, that's like just 4 times the length of your rocket.
Yeah.
When you did your test flight, did you have 10 pounds of weight in the nose?
We had around 6 pounds, I believe.
I think it's 6 pounds plus, like, so it was probably like 8 pounds total in the nose cone.
Yeah. We had to add quick links to the nose cone to ballast.
And as I recall, we also increased the number of sure pins that you had.
We did, yeah. We had 8. That's barring the little hiccup we had with our black patterning measuring system, which well, Elaine, just a little update. During our Seymour test flight, we did a ground ejection test with the nose cone, and we failed like 3 times in a row. And turns out we were using the wrong units for measuring a black pattern. We measured 2.5 grains instead of 2.5 grams. So we fixed
that's
that.
a big mistake. I know what you were using to measure with then.
What scale were you using?
No.
It was actually kind of humorous.
So were you using one of those buck powder reloader measuring tools, or were you just actually using a scale and had it on the wrong one?
Just a scale. Yeah.
Oh. We have the other kind. And I had to tell my husband about the difference between grains and grams in pharmacy terms.
I see. See, a pharmacist?
My background is as a nurse.
Oh, okay. I see.
I don't take care of patients anymore. I'm a researcher, but
okay.
Right. And I fly rockets.
I see. So how did you end up getting into rocketry?
It's a really, really long story, and it started 30 years ago. But I went to a rocket launch with my ex-husband and my kids, and I think I liked the rocketry more than the kids because they were really young right then.
I see.
So, yeah, I just never got out of it.
That's cool.
Yeah. I met my current husband at a rocket launch.
Oh, nice. All right. All right. So we have, a couple things. Yeah. So we just have increased the size of the main parachute, and then 40. Did you end up saying 42 feet for the drogue harness, the 18,000 up length? Did you end up saying that?
I would. I mean, with that much weight in the nose, I'd really like to see 50 feet.
50 feet. Okay. Yeah. Well, let me see how much we got here. We might be able to just add more shock cord length to one side, because our shock cord looks like a V, right? You have a drogue at the top, and then lower body tube one side, and then upper body tube other side. So if we just take the shorter one, replace it with the longer one, we might be able to up it to that 50-foot total length. I'm gonna take a look.
Or quick link two of them together.
But that's true. Do you think the quick link would become our source of actually they quick links wouldn't break, right? I mean, unless the shock would break before the quick link then.
I think you'd probably break the quick links first with that shock cord. That's like 7,000 pound Kevlar, and quick links are, a couple thousand pounds.
Yeah, I just don't want the shock cord. I don't want the quick link to become a point of failure.
Yeah.
In the shock cord. But yeah, I will take a look into that. This is really tangled. Unfortunately, I think it would take a long time for us to like actually untangle this like right now. So we might have to like work on that later, and then we'll measure out the full length and see if we can attach extra length to it. So, yeah, I don't know.
And Jim, how do you recommend that they hook them together? Tying them?
Well, I was going to ask if they have knots in them now, because if you have knots in there for the attachment point for the parachutes, for example, you're and
we have this right now. If you guys see this, it's a.
How many times has that one flown?
This one specifically?
Yeah.
Oh man, this one. This has got to be at least, I'd say at least 4 times, because this has been here since I even came to UT. So it's been around.
I mean, it's a whole lot cheaper to just buy 50 feet or 55 feet of Kevlar than to have them tell you at Spaceport that you need to go buy that because you've got crispy bits.
Okay. I see. So,
Give my technical talk.
Yeah, that makes sense. I'll keep that in mind by shop cord. Do y'all have recommended like suppliers that you guys would buy that from?
Well, for that particular, the problem is that you're not going to be able to find a shock cord that is 50 feet long, except to get it custom. I mean,
I know One Bad Hawk does it.
What's that?
I said One Bad Hawk does it.
Yeah, you'd probably have to go to One Bad Hawk and ask them to make something custom for you of that length. And if you were going to do that, then they can also put an attachment on the shock cord at the point where you want the drogue to be attached. So you could tell them to put what they call a third loop. And the problem you'll have when you do it with One Bad Hawk is that Teddy will tell you where that loop needs to be. And you need to tell him where you want it, and say something like, I told you to put it there, because otherwise Teddy will put it in the wrong place. He puts those third loops very close to one end, and you want it to be roughly a third of the way along the shock cord. But Teddy doesn't do it, so you have to insist that you want it there.
And with the custom job, he should do it.
Yeah, well, he'll fight you. I guarantee it. He'll tell you where you need it, whether he knows or not. That's just the way he is.
I've known Teddy a long time, and yes, he does think he knows best.
Yeah.
But don't we all?
So on the main, the 2 pieces of harness that you need for the main are like 2 pieces with loops on either end, and I would say they should be at least 20 feet, and probably not more than 25.
At least 20 feet.
I'm sorry?
Sorry,
Yeah.
you said clarify. You said main shock cord length. You say minimum 20 feet, but no more than 25 feet.
Yeah, in that range. And I like to make the one going to the parachute and the deployment bag just a little bit shorter, if I can. I mean, if I could pick two numbers, I'd say 25 and 20. You know, with loops on either end, but those you don't need. You don't need to have a third loop on those. So those can probably be bought directly from the site without having to be custom.
Yeah.
All right, that works.
You know,
All right.
on harness that thick, I mean, you can, I mean, you shouldn't need knots if you do what we just talked about.
Yeah.
If you had knots though, you need to be prepared to cite the reduction in the strength that will occur because of that knot. And,
Yeah.
and you can,
At your launch readiness review on site.
yeah. And you can find those statistics online, but best would be not to have to use a knot.
Yeah,
Then you avoid controversy.
Teddy sews his loops with Kevlar thread.
Okay. Well, right now we have. Does this count as a knot right here? Like,
Yes.
you see how we have a knot attaching our shock cord to our quick link. I don't know if that is what you guys.
That's a knot.
Okay, so that would decrease strength then, I guess.
Yes.
Yeah.
Yeah, I guess those are. I guess these are kind of unavoidable, right? Just because like you have to have a way to attach your shock cord to your, your.
Mhm.
So I guess yeah.
Unless you get, ones that are sewn.
So okay.
Yeah, I mean, if you talk to Teddy and get a 50-foot length of Kevlar, to have him do loops on both ends.
Oh, okay. So
So
the
you
loop.
And a third one a third of the way down.
Yeah, and then the third loop a third of the way from one end.
Let's see. Okay. All right, Teddy. He's the guy who's at One Bad Hawk.
Right.
Yes.
All right, I'll reach out to him later today. See what we can do. All right, I think that's good. So we got.
And tell him you're the UT team that didn't call him on his cell phone.
Okay. All right. Is he not like people calling him on a cell phone?
He does not like that.
Okay. Team that did not call him on cell phone.
And that Jim Jarvis and Elaine Russell told you to call them.
Okay. All right.
Maybe say Elaine Russell because he doesn't like me because I'm the one that gave out his cell phone.
Oh. Well, I probably have it, but I don't give out people's cell phone numbers. Especially not if they do as I asked the first time.
Yeah. Makes sense. All right. So we'll have you guys' names as our alibis, and if he's not happy with us, then we'll just point him to you. So.
Well, if you're asking him to do something custom, then custom is what you want, right?
Yeah, that makes sense. All right, I think that should get on turf recovery. Yeah, we unfortunately I don't think we have anyone from the payload team here today. But just generally with the payload, it's I can go over it real quick. Just in general, it's completely internal. This is what it looks like with the nose cone attached to this end right here.
Okay.
Yeah, so the nose cone will be coming like this, like that. And then we have a U-bolt at the bottom. This hooks onto our shock cord. It's a pretty thick U-bolt. If you take a look, it's I believe it's like 3/4, or what is this? It's like a 1/2 inch maybe. like a half inch U bolt, so it's pretty strong in there. And then the payload itself, that's mostly done by the payload team. It's going to be 8.8 pounds, well, by competition rules. And the idea is we can just slide all the payload articles in here at the prep area, and the payload itself should have enough battery and storage to go for at least like 3 or 4 hours. That's what the payload team told me. So we can just have it completely internal. We don't have to arm it on the pad or anything like that. And yeah, that should be the main idea behind it.
Okay, when you bring it up, when you're going to fly it, they're going to ask you to take that out so they can weigh it. Yeah. Are you going for the CubeSat, the 3U cube form factor?
I don't think so. I think with
square.
Yeah, sorry,
or
what?
Oblong? Is it like oblong, rectangular?
It is not. We initially tried to do that, but I think it ended up being too difficult for them to fit everything into that kind of shape. So it's just gonna be like a sled. Okay. Very similar to our eBay design, actually. The idea is that we'll have a couple of materials attached to the walls of the payload bay, kind of attached to the walls, like just some Velcro right there. And then we have a thermal camera on there that will look at those articles, those squares, and then during flight, they'll deform a little bit, and then we can measure the temperature change of that during flight. So there's like temperatures of materials under high acceleration.
Okay.
Yeah, it's pretty interesting.
Security placed is pretty much the same way with with long all thread. Going through your board.
Yeah. I don't know if they're using that anymore. I believe they have like a 3D printed housing that unfortunately we don't have. Actually, it might be in there. But yeah, there should be a payload box in there. This is like a 3D printed sort of like additional housing that they can just slide in, and then the housing provides structure for the sled of the payload, and also holds the camera as well, so it can look at the materials during flight. We actually flew at a few more test launch and worked pretty well there. We got a nice video of it.
Okay.
Yeah. So
and to point out the Kevlar string safety wire thing for the top of the zipperless coupler also. For however you're screwing the all thread into the motor and retaining the motor.
They got a U-bolt up at the top.
On top of our motor has a single all thread coming out of it, and it will have an eye nut at the very end to hold the shock cord for the drogue parachute. As Jim mentioned earlier, we do have a Kevlar strap method to prevent that eye nut from rotating, and that there's a hole drilled into the zipperless coupler bulkhead that where we can attach an eye nut to tie this Kevlar strap to.
Okay.
Yeah, this is our payload sled. Yeah, unfortunately, we don't have anyone on the payload team here to explain it, but so it looks like. So these holes are used we have a camera that's positioned about like this far away in the payload bay that will be able to look at these 4 materials, and you can see the temperature during flight.
Huh.
Just like that.
I think it's their initial one for the laser cut into 3D print usually or something.
Yeah, so yeah, this one did fly. Yeah, like mentioned, they're gonna redo a different sled to make it more custom to fit into the. This bulkhead was the one that broke off, but we have our main hole here that holds the all thread from the motor, and then this is the eye nut that we use to tie the Kevlar strap to. That's the basic idea behind that.
Okay.
And I keep switching ends of the rocket on you, but make real sure that the payload cannot move.
Yeah.
That's the one thing that you really need to kind of take a little extra care, making sure that because you don't want it being able to move a half inch, for example, because it'll
Yeah.
just end up being like a battering ram on the components, and so you want to make sure that it does not move.
Yeah, it does not slide around at all. Okay, that's good.
Well, the other thing is when if your payload can move and your drogue fires, it's a battering ram on the nose cone. Taking it out, you could break your shear pins and have your main deploy as well. And that would be really bad news at 30K.
Main deploy 30K. That's we're gonna be walking for days to find that thing, even if we have GPS lock on it.
Okay, can I see your motor retention?
Motor retention, yeah.
No, just show me the bottom of the rocket. You don't have to take it out.
Yeah, let's see. So the motor is actually retained from the top. So the bottom, there's a thrust plate at the bottom. That will transfer the force from the motor to the airframe. But on the top side, there'll be an all thread that sticks to the top of the forward closure. And then on the other end, we have an eye nut. And this is the eye nut prevents the motor from falling downwards out of the rocket. It's our thrust plate.
And how does it stay in place?
It's just really friction fit, I guess. Yeah, when we screw the motor in, it's really tight, and that friction helps keep the thrust plate in. It actually worked pretty well at Seymour for a test launch.
Have you done this in the past?
Yeah, we did it once before, so this would be a second time doing it.
Okay. Have you done it before with an O motor?
We've done it before with 2 N motors. And then the one at Seymour was an N25. Well, I guess so. Yeah, technically we haven't done with an O motor before, but yeah, we surely don't have any way to glue it. I guess we could glue it in. We could just put like a small layer of resin on the outside.
Well, that would make it difficult to get your motor tube in and out, would it not?
Well, we don't have a motor tube actually. But,
I mean, your motor case.
yeah.
How does your motor get loaded?
It just goes through the. Yeah. So this hole in the middle is designed.
If you're talking, Ryan, you just cut out.
Oh, yeah, all right. So like this hole right here, the inner this is designed to allow the motor case to go through. So it's like I guess like 4-inch.
Okay. I fail to see how it does anything to help keep the motor in place or transfer the thrust. Jim, can you help me out on that?
Yeah, I mean the motor thrust ring pushes on the G10 ring, and then the G10 ring pushes on the bottom of the airframe, and the motor is sized so that the holes are the same size as the motor case, so everything stays aligned. And then it all gets pulled together by the eye bolt at the top of that section. I mean, I do it this way all the time.
Do you? Okay.
I don't own any motor retainers.
Gotcha.
Never bought one.
I mean, I have used the a threaded eye bolt on the top of a motor to hold it in place, but I don't know that we ever ever did a thrust plate on the bottom.
Well, I mean, you have to have something there, right?
Do you? Depends on how far down your ring, the centering ring is.
Well, you wouldn't want to apply thrust to the centering ring. You want to apply it to something that pushes on the airframe. Otherwise, the motor could just fly through.
Here, we have our casing out, so we can show you how to slice
Yeah,
on.
that a visual would be really helpful.
Yeah, so you see the lip of the motor?
Never mind. I get it now.
Yeah.
I get it now. Never mind. Yes, that's what we've done in the past, Jim.
Yeah, I kind of like to have a stepped ring on the bottom, but in this case, the centering rings, are enough to hold the motor, exactly centered. So,
Gotcha.
the thrust ring itself isn't going to slide off to one side or the other. It's going to stay right on the bottom of the airframe.
Which also, by the way, I did want to ask something else. I guess when we cut our tube, we must cut it a little too short. So the tube isn't actually long enough to hold the entire motor. So what we're gonna do is gonna add an extra sleeve on the bottom of this motor, like a little extra fiberglass sleeve, about 1.5 inches, just so we can back the motor out a little bit, so we have enough space inside the bottom tube of the airframe to hold the whole motor. So it looked like this with the fiberglass. Where my fingers are, there's gonna be fiberglass.
Okay. Can you put the motor up next to the rocket so we can see where the top of the motor goes to?
Yeah, so I'll have them. I'll go from this angle. You want to put it in, or yeah? So this is our total length right here. It comes from the other side, actually. What it looks like.
Yeah, you're pretty close.
Yeah. And
is a 2-inch sleeve going to make it long enough? Can you not just you have a coupler there, don't you? Put another piece of body tube and another coupler at the top. I know it makes your rocket longer.
Yeah. Wait, what were you saying? Another like sleeve on top? Like you mean right here?
Yeah. And just make your body tube longer.
Another coupler and then the top.
Instead of having having the motor hang out the bottom of your rocket.
Okay, I guess that could work.
Jim, what do you think?
Well,
Bible.
they're using a zipperless coupler, so I mean, you would have to. I mean, you would end up adding. Okay, you put a piece of airframe on there that is about a foot long. I mean, it'd have to be longer than that. It would have to be long enough so that you could then glue in the zipperless coupler. So you're going to add a foot of length to it.
How does that change your stability?
I think I would go with the 2-inch section on the bottom. But when you do that, you need to make sure that everything is nice and square, and nothing can get by. I don't exactly know how to describe this. Don't use a thin piece of wild man to do. I guess you got to find something that is that won't fail under thrust. Let me just say that.
Yeah.
Do you think fiberglass airframe would be strong enough for that? Like something like this material.
Not the thin walled stuff.
Not thin wall.
Yeah, I mean, I guess conceptually, airframes handle motor thrust all the time. So from the point of view of the compressive strength of the tubing, it would be strong. The part of it that bothers me a little bit is, if there's any gap in, in the thrust ring, for example, that the motor, that airframe could slip through, you know what I mean?
I see.
Yeah, I mean, I'll think about that a little bit because that would bear a little scrutiny, and you just want to not have anybody be able to poke holes in what you're doing there.
Yeah, because unfortunately, I won't be at Spaceport this year.
Oh,
I had surgery just a couple months ago, and I'm not up to a week in the desert. Not
Mhm.
yet.
Yeah,
So, so Jim, you're going to have to back me up. Whoever looks at their rocket.
well,
Yeah.
it'll probably just be some random reviewer, because
Yeah.
I can't, so I don't know who it would be, but
I could always ask Ben.
yeah, because see, the thing that I see is that the thrust ring hole is not exactly the diameter of the motor.
It-
Right,
a
there's a
little-
little bit of a gap there. You can kind of see through it. And so, is there any chance for thin walled fiberglass tubing? You're not going to get an exact, 100% contact of the wall with the thrust ring. I mean, it's almost what you need. I mean, and I think we talked about this at one point. Maybe that you would fabricate something out of a few 2 or 3 pieces of plywood or something, so that you're pushing on the plywood on one end, and then you've got much greater contact against the thrust ring.
Yeah, just make multiple thrust rings out of plywood.
Yeah, or you could eliminate the G10 thrust ring and just do the whole thing out of plywood.
Yeah.
So
Okay.
in other words, you would cut maybe, enough plywood sections to maybe make a 2 or 3 inch long piece, and then cut a hole down the center of it, and cut the outside to fit the airframe, and just do it that way.
Okay. So like you're thinking like something around this thick, just in plywood, and you're just adding it on.
Well,
Really?
what I'm thinking is something like the thrust ring, only instead of being a 1/4 inch thick, it's 2 inches thick.
Okay. So just like that much, and that much you should like make it plywood.
Right, yeah, just like the G10 thrust ring, except instead of being a 1/4 inch thick, it's like 2 inches thick.
Would you be worried about the structural integrity of wood at all?
Say again?
Would you be worried about structural integrity of wood?
Well, I wouldn't be concerned about it, but I would be very careful to make sure that the hole that I cut in it is a nice firm fit over the tube, and not any not any slop around it, because those thrust rings are not very wide, and you want to make sure that the thrust ring makes good sound contact with the plywood, and it doesn't wiggle. And be sure to put the closures on the end of the motor so that you know exactly how long that thrust ring has to be. Because remember, the forward closure on the Cicerone motor has a stem on it. So put that in and make sure that everything's going to fit once you put in the plate.
All right. Yeah, that makes sense. All right. Anything else on the motor retention side, or sizing?
The other thing that occurs to me that you could do if you wanted to do I mean, you can buy centering rings that will fit over the motor. Right? I don't know, we seem to be having some audio problems.
Yeah, Ryan, are you talking on your phone or your laptop?
I'm talking on my phone. Is that the issue?
I think it is.
Okay, let me switch to my laptop. How about now? Can you guys hear me?
Yeah. Oh, now you're echoing. You need to. Oh,
Um. Okay, how about now?
now you're good.
Okay. All right, there we go.
Okay, here's another idea that you could consider. You know, you could buy a centering ring that fits. I mean, basically, that looks just like the thrust plate.
Okay.
I may not get this 100% right, but you know, as far as the ID of the thrust ring goes, or of that centering ring goes, I mean, you can buy what are called airframe centering rings or coupler tube centering rings. And you'd want the coupler tube centering ring because that's the one that would fit over the motor.
Okay. Airframe center rings, I know.
And if you were to buy a centering ring that fit over the motor, you know, then you could buy 10 or 15 of those and just stack them up, and that could be your spacer.
Okay. Let me see. 10 to 15, would that be a little too thick, you think?
Well, I don't know. I mean, if they're a quarter inch, you'd want probably 8 of them. You know, if
Okay.
they're 3/16, you'd need 12. So, you know, however many you need, but you just buy however many you need. You know, and that way you don't have to cut anything. You know, someone will do it for you.
Yeah, that makes sense. I'll look into that as well.
Yeah, and then you know you just continue. I mean, and you don't even need the OD of that to cover the end of the airframe. You know, those rings could be you know, a quarter inch wide, but it would provide a lot more surface against the thrust plate than an airframe tube would.
Yeah, that makes sense.
See what I mean? I mean,
Yeah.
now you're bulletproof if you do it that way.
Do you think we could buy one of those center rings, and then use the fiberglass airframe?
It depends upon the tolerance of it. If it's the same as the thrust plate, it doesn't help you.
Yeah, I see. What I'm seeing is, we draw this out. It's the motor. So we have So can you guys see this picture right here? This diagram? So like right now, this is the motor in the middle. This is our current thrust plate. This would be the wooden centering ring that Jim just mentioned. And then you're thinking maybe like a small sliver, like 1.5 inches or 2 inches of fiberglass right here.
Well, the issue that I see is that fiberglass tubing, you know, the end of it where you'd square it off, that has to fit precisely up against whatever is that contact surface.
Okay.
And you know, in the case of the thrust plate you have now, it's not sized exactly as the motor tube is. There's gaps in it. So that means some of that airframe tubing would not be supported on the end.
Yeah.
Okay. And you want it to kind of be 100% supported. So if you had a ring there that was, you know, very close tolerance to the you know, to the motor tube, then what you're talking about would probably be fine.
Okay.
But I think, you know, that's the issue. I mean, this is a, you know, a matter of you know, constructing it so that that it passes the smile test of being able to transfer the force. You don't want gaps in there where that might effectively weaken the airframe tube because the end of the tube is not actually being supported by the thrust ring.
Yeah, I see. Okay. Yeah, I think this method might work because we would have our thrust plate right here, a current thrust plate. We'd have a center ring, airframe center ring that'd be very close tolerance to the motor casing, and then the fiberglass sleeve would butt up against the end closure of the motor and the very big tolerance airframe centering ring.
Yeah, I mean, I just think you need to have something that's a very close fit to the motor so that all of the airframe tube is supported. I mean, you could do it with the thrust ring only if it was, a little closer tolerance.
Yeah.
Go.
What was that?
I was talking to my dog.
Oh, I see.
I'm sorry.
I heard go. I was like, wait, what do I go do?
Nope, out of here, out of here.
Wait, is that your dog as well?
I was joking.
Oh,
It was part of the joke.
okay. All
I was
right.
telling you to get out. No, it's okay. Keep going.
Not yet. Maybe once you're done, then I'll get out.
So when you do stuff like that, it's important that, like that fiberglass sleeve, that it be really square. You just can't cut it off and hack it off with a hacksaw and expect that it's going to be square. It won't be.
Yeah.
So, when someone looks at that and evaluates whether or not it's going to work, it's the craftsmanship of how it's cut is important.
Yeah, it makes sense. Yeah, in that case, with our connection point between the thrust plate and the fiberglass sleeve, that wooden piece we might just go buy that because the way we cut it may not be as accurate. So you might just purchase that off the internet somewhere.
Yeah, I think if you were going to use that piece in combination with the fiberglass airframe, I don't think I would make that out of wood.
You do not? Okay.
Because you can imagine the fiberglass airframe just kind of cutting right through the wood.
Yeah.
And so I would, if I were going to do that, I would get a centering ring. I mean, what I would do is just make the thrust plate the right size. Just remake the thrust plate so that it fits.
Yeah, I guess.
I mean,
water jet.
I mean, the problem is the hole is just a little bit too large.
Yeah.
But, again, though, it'll be real important for that fiberglass sleeve to be square on both ends.
Yeah.
And, if it's not, it's going to have an asymmetrical push on whatever it's pushing against. And that can lead to a failure of something or another. So, you have to make that square, and that's not a trivial thing to do.
Yeah.
It's easy to make one end square when it's part of a longer tube. But when the tube gets really short, it gets a lot more difficult to make that square.
That makes sense. Leave any idea about this. Yeah, I think it's easier for them to get on it and yeah. So let me go up. Boom, boom, boom. Yeah. So we might as well go with this one as well. This design, fiberglass, thrust plate, and then there's a bunch of wooden centering rings that fit on that are very close tolerance to the motor casing, and then they rest on top of the enclosure.
Yeah, and like I said, might be able to just buy G10 centering rings that do exactly the same thing.
Okay. So
And,
yeah,
I mean, you might need 12 of them, but you know, the vendor can pull them off the shelf and then you're good to go.
yeah, and they're probably pre-cut exactly the size as well.
Yeah.
And I think that, like I say, they call them centering tube. Well, you just have to make sure that the centering ring, you know, normally you would get a centering ring and it would center a motor tube that is around the airframe.
Mhm.
Yeah, but you want one that doesn't go to the airframe size, but goes to the motor tube size.
Mhm.
And you know, some vendors will have both. You know, I mean, if you go to the Wildman site, you'll see centering rings that are sized for the motor and for the airframe.
Okay. Yeah, that makes sense.
Then it makes the job pretty easy.
Yeah, I'm looking to getting some of those.
Jim, would you recommend that they glue them together?
I don't really think they need to be.
Okay.
Well, everything's going to get pulled together in a sandwich.
Mm-hmm. Yeah, that's true.
The tube's going to be aligned from the centering rings, and so you know, I don't think it's going to go anywhere. But on that question, let's look in the back of the rocket again. What are the positions of the centering rings? I know I've looked at it before, but I'm
Yeah. So
let's just take a quick look. Yeah, so you've got 3 of them in there. So the motor's going to stay centered.
Mm-hmm.
Where did you get those centering rings from?
these ones,
Yeah,
they're we just laser cut them.
did you cut those?
Yeah.
Yeah, because that's basically what you want for this motor adapter we're talking about. It's just centering rings like that.
Okay. That works. Yeah, and you're thinking like with this design, like you think these can be made out of wood? Because like I know fiberglass can get really expensive if we make all of these out of fiberglass.
I'm sorry, say that again.
So
Could they
like
be
the
made out of wood, and then what did you say?
yeah, so these center rings that are used to space out the distance, you think they can be made out of wood? Just like the ones we had in a rocket already.
I mean, yeah, I mean, they could be made out of wood, yes.
Okay. All right, that sounds good. We can. That helps us a lot. Wood is a lot cheaper. So we can. All right. Yeah. Any other questions on?
Do you have any questions?
You mean me for you guys?
Yes.
Yeah. Anything or? I guess this is more of a supplier question, but I did want to ask about. I don't know if any of you guys know about Animal Motor Works about their rocket motor situation. We did buy a motor from them. We actually bought an 03400 from them. They said they're going to ship it to Spaceport. I don't know if you have heard anything on the status of that yet. Maybe that's just something I should
Well,
ask.
they won't ship it this far ahead.
Mhm.
Well, I mean, I think they are going to be on site for one thing.
Okay.
And so is Wildman.
I'm sorry, what was that?
I said Wildman as well.
Yeah, so I think they are going to be there. And if they're not, you know, John DeMar will arrange to have all the parts there.
Okay. Yeah. And that means we won't be able to assemble the motor until we get to Spaceport.
That's
Right.
correct.
Okay. Guess that's all right. Yeah. I mean, I'm trying to remember how we did last time. Last time we needed some glue in there. But yeah, I guess yeah, we can get it from them there, and then Probably build it in our Airbnb, right? A case.
I suppose.
Yeah, it's just the only way to do it.
Yeah, when you get there and before you start doing anything, I mean, let's get together and look at the parts that you have for it. And the one concern I have is that I believe the 03400 is put together using HTPB as the glue.
Ah, yes, I do
And
remember that.
and as opposed to like the Gorilla Glue or some other glue that, you know, it's one of the few that are put together that way. And you have to be very careful when you use that glue. A very common mistake is to not adequately mix it. And the problem that happens when you don't adequately mix it is that it never sets up. So usually you have to remove it from whatever container that it's in and put it in something where you can mix it really well before you use it. So, you know, the motor you're getting is a little bit piecemeal, so I'm not precisely sure what glue is going to come with it. And so we have to make sure that you have the right glue, and if you don't, that there's a substitute for it. So we'll need to follow up on that in the, you know, the day or two before you get there and make sure that, you know, we've got what we need for gluing the grains.
Yeah, it makes sense. I do remember reading that the 03400 reload kit provides the glue for you. I don't know if you guys know that for sure. Do you guys know anything about that?
If you bought one off the shelf, that would be the case. But the one you're getting is not quite off the shelf.
I see.
It's a little bit of a retread. So we need to, you know, that's something that we need to follow up on and make sure that we have the right glue for it.
Yeah, because my team bought, it was not an O, it was an L, but it required, they asked for, it was Elmer's Max.
Almost.
Anyway, and I think it was an Aerotech motor anyway, but still, they didn't supply it, and you know, it wasn't something that he could find on the shelf in the area. So he had to order it from Amazon overnight and come back to put his
I
motor
see.
together. So yeah,
I'll
what Jim said
follow
makes
up on that with John
sense.
Barr and make sure that they have that glue with it.
Okay. Okay, awesome. That'd be amazing.
Yeah, because that's the one thing about that motor that you have to be careful about, and that is that glue.
That's good to know. All right. Yeah, I think that's mostly on the technical side. I mean, Jim, do you have like your accommodations or whatever yet at Spaceport?
Yeah, I think I'm getting an Airbnb with other ESRA people.
Okay. Yeah, I know one of the rules was that teams should be able to provide accommodations for the flight of record. But if you already got that taken care of, then should be good there. Yeah. Yeah. Other than that, just like on the logistical side of things, we're bringing I think 14 people total, which is actually a really high number than what we usually bring. Which is good to got some more members getting experience. But yeah, really excited for Spaceport and you know, see what we can do out there.
Don't forget water, sunscreen, and a wide brimmed hat.
Yep.
And closed-toed shoes.
Yes, I will ensure that all the members do that. I do remember last time we were out in the desert hiking for like 3 days just trying to find a rocket.
That's rough.
Yeah.
So I highly recommend the 50 SPF fishing shirts. They're long sleeve, but they're really lightweight and they breathe. So it'll help keep you as comfortable, if not more comfortable, than lots of sunscreen all over the place, which tends to get sweated off and not put back on very frequently.
Yeah, that makes sense.
That's my attire of choice out in the field.
Yeah, makes sense. I did hear they're gonna
I
have.
always wear long sleeve shirts, and another thing that's kind of handy you know, Harry wears these little gloves that they don't have fingers on them, but
Mhm.
the rest of the glove. Because the thing that ends up burning on me is the back of my hands. And so, that's the spot.
Yeah.
And so like I say, Harry has these gloves that he uses that, they cover up his hands, but not his fingers, so he can still do stuff. But
I
but he
have some.
doesn't
I have some
burn.
too.
Nice.
They are very convenient.
Okay. We could looking at getting some of those. Yeah. Although I
Hiking
did
boots,
hear.
sneakers.
Sorry, what was that?
Hiking boots, not sneakers, not sandals.
Yeah, you remember last year we had I think one or two members come with like tennis shoes, and then the thorns out in the
Yes.
desert were just poking through their sandals. They were literally pulling out thorns out of their shoes afterward. It was quite
Yeah.
scary to see.
It'll go right through the bottom of your foot, through your
Yeah.
through your sneakers.
Yeah,
So
that's pretty scary. All right, I'll make sure to do that. I was gonna ask, they said they're gonna have tents for everyone, right? So like theoretically wouldn't have to bring tents.
Well, I mean, that's what
yeah.
they're saying is they're gonna have, it'll be you know, like a big circus tent kind of a
Yeah.
thing.
Yeah. Circus.
Like if you remember last year where they had the Da Vinci located and they had those tents set up and like I think that's what they're getting. So those will be pretty good.
Yeah.
You probably don't need to bring your own tent.
Yeah, you might bring one just in case. But I do remember because last year, I don't know if you guys were there when there was a dust devil that came through the prep area, and it literally picked up like ate all the tents and like blew them away into the desert. Like the medical had people in them, and it just like completely blew the medical tent away. And it was pretty scary. But,
Yeah, it was a little breezy.
yeah, a little breezy, yeah, to say the least.
It's always a little breezy at one time or another.
Mm-hmm. Yeah.
So yeah, if you can make sure that your that the tents that you're under are staked down well, because you never know when one of those dust devils is going to come up.
Yeah, for sure. It's the price of doing business in New Mexico, I guess.
Uh-huh.
Yeah.
And in Virginia, we happen to be in a place that gets thermals late in the afternoon,
Really?
and that we have had tents that were staked down, picked up, and dropped on people's cars. On
Wow.
you know, we don't have anything that big. It's mostly pop-ups, but you still don't want something like that landing on your car.
Yeah, I mean, that
your
would
head.
not be good. Yeah. Yeah, so I think that's pretty much it of what I wanted to ask, or yeah, what we wanted to ask for you guys. So if you guys don't have anything else for us, then we can end the call there, and we'll definitely keep in touch over email. If you have any questions, I can reach out to you guys.
That would be lovely.
Yeah. All right. Well, I just want to say,
Good.
all right. Were you saying something, Jim?
No.
Okay. Yeah. Well, I just want to say, thank you so much again to both of you guys for taking the time today to call us. I do really appreciate that, and helping us take this one step closer to getting to the Spaceport competition. So definitely appreciate you guys for that.
Well,
No
you're
problem.
welcome.
You're very welcome.
Yeah. And Elaine, yeah, I guess I don't know if we'll see you at Spaceport, but I do appreciate you reviewing all of our progress reports, doing all that work. I'm sure a lot of teams going on, especially with the surgery too. I imagine you have quite a lot going on. So definitely appreciate for that. And then yeah, Jim, we may come by your house sometime if you want to take a look at the rocket physically. But nevertheless, we'll see you at Spaceport either way. So
Okay, well, you're welcome to come by if you need to. Although you're going to have to dodge 13 more video reviews over the next couple weeks.
oh man, you got quite the schedule ahead of you, I imagine.
Yeah, there's some teams that aren't scheduling, so I'm starting to think maybe there's going to be some attrition.
Yeah, I have
Slowly
several.
but surely, they're all starting to come in.
Yeah.
you know, we'll
All
see.
my foreign teams have left.
Yeah.
I'm
Well,
glad.
I have one German team and they're coming, and two Canadian teams.
It's Canadian teams.
One is and one I'm not so sure about, and then all the rest are domestic.
I have I do still have one Canadian team left, and I believe they've already scheduled they reached out early.
Yeah.
Not as early as you, Ryan,
Oh.
but they reached out early, and I was happy because, you know, I have my own team's reviews that I need to help them with. So, yeah, it's quite an interesting time.
It'll be fun.
Yeah.
Oh.
Sure. It'd be quite a grind from here.
There.
Yeah.
Well, I think the video reviews are useful. You know, you get to see hands-on what's happening. So I think they're worth doing.
Yeah, sure. But yeah, best of luck with the rest of the video reviews, and for all the work you guys are doing. So yeah, I guess I'll see you guys soon, either in person or online. So yeah, thanks for everything, guys.
Oh, you're very welcome. Have a good evening.
They get to work.